Okay, so what we're going to have to do is we're going to have to zoom out. There's just too many concepts in calculus for me to get them all on this. And I thought about not having all of them in one, but I think that you can zoom in on this video. You can zoom in to a lot of things in general. So hopefully you can zoom in to see these new concepts we've talked about here. So we have parametric equation. Here, a plane curve. We have that here over here somewhere, plane curve. And if you're just joining us, you don't know how this works. I say a word, you repeat the word. I say parametric form, you say right after that parametric form. You need to be able to verbalize and think about these terms for communication purposes. So make this into an exercise, not simply a sit back, watch, and enjoy the show. All right, so we have the circles and ellipses. Yeah, we added those in here, circle, ellipse. Then we have conics and hyperbolas, conic, hyperbola. So let's move these over since we have a little bit more room now. There we go. Parabola. Where did I put that? Right here. Okay. Parametric form. Parametric form. Differentiation. I mean, that really should have been over here with the derivatives. Differentiation, the process of. So let's add that right here. Differentiation. Area in the plane. Area of a surface. Area in the plane. Length of a curve. Length of a curve. Area of a surface of revolution. Let's go ahead and move these over here. And because these seem to be slightly different, we'll add them here. So area of a revolution surface. Now you should be aware that the concept of revolution, earlier we have a revolution solid. So I think when you hear the word revolution, it's an actual solid. We'll find out. Area of a revolution surface. Volume of revolution. Area in a plane. And that would be revolution volume. Here's revolution surface. Let's move this up here. Somewhere in here we have a revolution volume. Do you see it? There it is. Volume revolution. But I think it should be the opposite. I think it should be revolution volume. Now we have the polar system, polar coordinate system, and polar graph. So we have polar graph. And we'll add it here next to the other polar coordinate. We'll put it here. Polar coordinate system. So there must be a large system that deals with polar versus nonpolar. Polar equation. Wow, another type of equation. So many types. Polar equation. We have conics and their graphs. So maybe lots of things have a graph, and then we have conic over here. So polar equations of what? Of conics. And what their graphs look like. Special polar equations, yeah, everything's got something special. And their graphs. Polar form. We have parametric form, but we didn't get polar form. I like the word form. Area in the plane. Area in the plane. Length of a curve. Length of a curve. Surface area. It's actually surface area would be rather important. Surface area. And the revolution volume, but working with polar forms. Awesome. Okay. So now we are on to vectors in the plane. That's this author's last concept in his calculus concept list. So let's condense these a little bit here. We'll go ahead and move these polar coordinates over here because now we're going to be focused on vectors. Alright. So we haven't even used the word vector. So now we have the word vector. Vectors in the plane. Now you have area in the plane, but that means a vector must not be an area. Vectors in the plane. There we go. Vector operations, dot products, dot product. Vector operation. Vector valued function. There's another type of function. In this case, it's in the plane. The derivatives of the vector valued function. The differentiation of the vector valued function. The integration of the vector valued function. Very important, vector valued functions. Projectile motion. Now, this is more physics related. Projectile motion. But many things can be placed in motion. Motion along a plane curve. Motion along a plane curve. And we have different types of vectors. We have a tangent vector, and a normal vector. I say tangent vector, you say tangent vector. I say normal vector, you say normal vector. Arc length. So we need to know what an arc is. We need to know what an arc length is. Curvature along a plane curve. So what is the concept of curvature? And then how do you measure something, but measuring what? The curvature along a plane curve. Let's go ahead and add measuring over here. See if that's different than calculating. Acceleration. That's another physics term. Acceleration. So vector components of acceleration. What is a vector component? Interesting. All right, so we have so many calculus concepts. So whoever put this site together has, seems like over 100 different topics. So let's see how many we end up having. I'll squeeze him over here. And again, the order in which these things aren't that important, aren't nearly as important as the concepts themselves. Once you see them and hear them and say them aloud, area in a plane, arc, isocline, slope field, curvature, arc length, then you'll be able to be familiar with these. So we got 1, we got 2, 4, 6, 8, 10 by, what is it? 2, 4, 6, 8, 10 by 2, 4, 6, 8, 10, 12. So 10 by 12 is 120. And we have 3 by 2, 4, 6, 8, 10. So we have 30 here, plus my 120, 151. So you have just learned, if you stayed with me through the whole thing, 151 concepts of calculus. And you can rewatch this video, and when you see Riemann sum, you can say Riemann sum. L'Hopital's rule, you can say L'Hopital's rule. You can identify different types of notations, different types of decays, different types of functions. All right, enjoy 151 calculus concepts.